welcome to this lesson video for finding domain of a rational expression. It's exactly what our learning target is, so let's jump in and get started. First up though, pop quiz, let's kind of remember some of our factoring. So two specific types. When we need to take out the GCF versus when it's like an X puzzle or reverse foiling kind of factoring. Whichever it belongs in, that's the section we'll put it in. 3x, let's just start from the beginning. 3x plus 12 is a GCF. There's no x squared, so it can't be a reverse FOIL, X puzzle kind of factoring. So what is this guy's factored form? It would be, let's see, they both share a factor of 3, so we would take the 3 out, and we would have x plus 4 left in the parenthesis. So basically you're just reverse distributing. If I were to distribute the 3, I should end up back to what I started with. Okay, so that takes care of the first one. The second one, hey, that's a 3-termer and he belongs over in the X puzzle. So I don't have space to draw X puzzles each time, but what you need to ask yourself is, what will multiply to negative 21 and add to a positive 4? Well, you should know that since it multiplies to a negative, you need an x minus and an x plus. But what numbers should be negative, what number should be positive? Let's see, 21 is 3 and 7, and we need 7 to be positive. So when they add together, they add to a positive 4. Okay, so now the second one's done. Moving off to the right still, let's see, x squared plus 4x. Hey, that looks like an X puzzle, maybe, but they actually both share something in common, so it's a GCF. X squared plus 4x, what is it they have in common? Yep, an x. The x comes out front, kind of like the 3 in the previous one, and what we're left with again is x, maybe if the computer will catch up with me, there we go, x plus 4. So that guy's done. Next one, x squared minus 25. Now, do they have anything in common, the two terms? They don't, so it must be one of these X puzzle things. And it is. It is like a reverse FOIL. What multiplies to negative 25, but adds to 0, because there's no middle term? So that would be, obviously I need one of each sign, an x minus and an x plus. Multiplies to negative 25, adds to 0? Well, that's got to be 5 and negative 5. So let's move to the second row here. I can definitely tell they both have stuff in common. So let's see, the greatest number that divides 18 and 6, well, that would be 6. And they each have an x. So we're going to take, whoops, what am I doing? I can't write that yet. I got to write the original problem. Doo-doo-doo. Okay, 18 x squared plus 6x. And I'll pause it because I'm not going to wait on the camera. Okay, so like I already talked about, they share a 6x. What can I multiply 6x by? That would get me back to 18x squared. Well, that would mean you would need a 3x. Oh my goodness. And what can you multiply 6x by that would keep you at 6x? Well, a 1. So we'll just do a plus 1. Okay, x squared minus 9. X squared minus 9. Hey, that's kind of like this one, x squared minus 25. It is factorable with an X puzzle. What multiplies to negative 9 and adds to 0? Maybe you can kind of guess it already. Whoa. Guessed it already. X minus 3, x plus 3. Alright, so that guy's done. The next one, 5x cubed plus 20x squared. They both share stuff and they have stuff in common, so it's a GCF. 5x cubed plus 20x squared. So let's see, what do they have in common? 5 and 20 are both divisible by a 5, and they both have, they both have an x, but they actually both have an x squared. If I'm talking about, the greatest common factor, they both have an x squared that I could technically factor out. So 5x squared times what would get me back to 5x cubed? Just another x. Plus 5x squared times what would get me back to 20x squared? Well, I've got the x squared taken care of. I just need to multiply 5 and 4 to get the 20. Okay, and lastly, the last guy, yep, he's going over here. He's another x puzzle. Let's see. We want to multiply to a 55 and add to a negative 16. So it multiplies to a positive but adds to a negative, so I need one of each sign. No, not one of each sign, sorry. Multiplies to a positive means I need both to be the same sign, sorry. And to add to a negative means they both need to be negative. So let's see, what multiplies to 55, and that's negative 16. I think this is going to be a negative 11 and a negative 5. Alright, so that's just a good review of factoring. What's up next is actual finding the domain, okay? So the reason this is important, rational expressions are fractions that have, expressions with variables on the top and the bottom. And so you've got to be careful because there's a big difference. If you type in your calculator 0 divided by, I don't know, like 13, it's going to give you an answer of 0. 0 divided by anything is 0. However, if you flip it around and do 13 divided by 0, your calculator is going to go ballistic. It's going to say undefined, and it won't be able to do it because you are never allowed to divide by 0. Okay, that's an error. You can't do it. So the domain is a way to figure out which values would cause zeros in the denominator, and we have to exclude them since that's not allowed. That's kind of the purpose of the domain. So for example, if I look at this fraction, I'm only worried about the denominator, okay? Here's how I would write my domain. I would say that the domain is all real numbers work for x. So I use this special R to denote real. So all real numbers work for x except one number. What number would I subtract 1 from and I would end up at 0? A 1. So everything would work except a 1. If I plugged in a 1, then my calculator would go ballistic with an error. Okay. Now, if you don't know the number, it doesn't make sense to you, whatever the reason might be, you could always set it equal to 0. X minus 1, set it equal to 0. Okay, what we're trying to avoid to figure out what x would cause that. And so since I have to add 1, you can clearly see an x value of 1 is what would make the whole thing equal 0, which is what's bad and I need to exclude. Alright, let's try another one. Woo! This guy. Okay, so the domain. Everything would work except what can't x be? Well, let's see here. I could factor this guy, like we just got done talking about. They have a 2 in common. And so, let's see. 2 and a 3, right? So I don't have to worry about the 2 when I'm thinking about the domain. It's this x plus 3, because what would make 2 times x plus 3, what would make that equal 0? Well, 2 times 0 would be a problem. So what would make x plus 3 equal 0? Well, that would be plugging in a negative 3, because negative 3 plus 3 would equal 0. So that gives me my exclusion. Alright, again, you might be tempted to do stuff with the top, but when I just asked for the domain, all we worry about is the bottom. Now, what number could I square and then times by 5 and add that together and subtract 6? That would equal 0. Whoa, really? That would take forever, guessing and checking and all that stuff. Ugh, I wouldn't do that. What we need to do is factor him. Is this guy coming? There we go. That guy needs a next puzzle. So you know what multiplies to -6 and adds to a +5? Well, I know I've got one of each sign since it multiplies to a negative. I think it'd be a -6 and a +1. Multiplies to the top, adds to the... Did I just say that backwards, or... I don't know. If I said it right and I wrote it wrong, I don't even remember what I said now. But I know that wasn't right. I know I need to multiply to -6, add to a 5, one of each, but I need +6, -1. There we go. Goodness gracious. Okay, so this denominator is equivalent to factored form x plus 6, x minus 1. Now remember we've talked about this in our solving. You know, when this equals 0, which is what I'm trying to avoid, that means either this group could have been 0 or the second group or both of them. So I need to take it group by group. What could I have plugged in that would have made that equal 0? And also I need to check what could I plugged in here that would make that equal 0. Well, I'm not going to show those solving because that should be simple and we should be okay with that. Everything would work except a -6 because I would have to subtract. And here I'd have to add 1, so a +1. Those would be the two x values that would make this result in a 0. Okay, and that's what I'm trying to avoid. Now, here's a fun one. Again, just worry about the denominator, don't worry about the top. What could I plug into that would make that 0? So 2 times y. What would make that equal 0? Well, if you think about it, 2 times what number would make that equal 0? You could divide by 2 if you needed to see the solving, and 0 divided by 2 would make y equal 0. So that would be my domain. Okay. Everything would work, all real, except, oops, not an x. I need a y. Except y cannot be that 0, because plugging in a 0 for y would make the whole thing be a 0, and that would be bad. Alright, I think I only got a few more examples. Yeah. We factored this earlier with an x puzzle. You know, what multiplied to -25 and added to 0? It was a -5 and a +5. And so the domain would be everything would work, all real numbers would work for x except +5 and obviously a -5. So everything would work except positive and -5. I think I got one more for you. Yeah, this one looks familiar. Kind of like the last one we just did. The only difference was there's a plus instead of a minus. So let's see if I can do, you know, the same thing I did and get like -4 and x plus 4. Well, let's see. Those add to 0 like they're supposed to. But what do they multiply to? A negative times a positive multiply to a -16, which is not what I want. So, rats, that doesn't work. Do they have anything in common? No. Okay. Well, if I think about setting that equal to 0, let's see, I'm going to have to subtract 16, and then I take a square root, and so I'd have a square root of negative, and I have a complex number. Man, what's the deal? Well, here's the deal. Because when you solve this, you got a complex number. What that means is all real numbers work. The only ones that don't work would be a complex, and so we don't worry about those. So that's it for this lesson video. The next I would suggest would be simplifying rationals, but keep learning and have fun, and I'll see you next time.